Good morning, guys.
Good morning, sir.
Am I audible?
Yes,
Yes,
sir.
sir.
Okay. Right. So today the end of geomorphology. Right. So we have seen fluvial landform. Fluvial, you saw, it is the action of river. The fluvial landforms are created. Now it is glacial landforms. Okay, I think in yesterday's slide itself, I have included this glacial landforms, and I think already you got this slide. Okay, right. Anyway, so the glacial landforms. What do you know about glaciers? I hope you know something about glaciers, right? So, what do you guys know about glaciers? What do you know about glaciers?
Sir, accumulation of ice.
Yes, it is related to ice formed by melted snow. No, Kartika. Snow is glacier, not melted snow. Melted snow means it's water. Right then, anything else? Then anything else apart from that? Above the water bodies. Yeah, for example, India's lifeline, the Himalayan rivers originates from glaciers. For example, if you see Ganga, it starts from a glacier called Gangotri Glacier, and Yamunotri. So, right. So, glaciers are important lifelines of India. So, yes, good. Then, what else you know about glaciers? Holds high purity water. Oh, okay, good. Many years of accumulation. Yes, right, good. So, I hope you people know about saffron, right? Saffron. Yes, good. Where do we get saffron from? From which part of the country?
Jammu, North.
Jammu and Kashmir, right? So, the Kashmiri saffron is known for its purest, finest quality. The reason is saffron naturally grows in only one type of soil. Okay, the soil is known as Karavas soil. Okay, Karavas. Okay, so this soil comes from glacier deposition only. Okay, that's why only from Jammu and Kashmir we are able to get saffron. Saffron naturally grows in the Kerala soil, which are the deposits from glaciers. Okay, so economic significance is also there for glaciers. Apart from just being a lifeline, glacier also the glacial deposits creates a kind of soil, that is the Kerala soil, which gives saffron. Okay, saffron is grown in only that part of the country. Okay, so our country majorly depend upon the glaciers, right? So coming back to glacial landforms, so we have different landforms within glaciers. Okay, we have valleys, we have snow, ice-capped mountains. Okay, so a lot of glacial landforms are there, and that's what we are going to see today. Okay, first is the erosional landform. So obviously, both sides will be there. Erosional landform and the one side that is the depositional landforms, right? So some of the important glaciers of India, I hope you already know Gangotri, right? Gangotri, you already know, which is the head of Ganga, and the Siachen Glacier. Okay, so these are some of the important Indian glaciers. So this is the erosional landform of glaciers. Okay, so you are seeing something called Hanging Valley, right? Something called Hanging Valley is there, and just a minute. Right? Hanging Valley, Eriti, Horn, Don, Noster Lakes, Circus, Glacial Trough. Nothing. See, the maximum the question that you are going to get in UPSC if you are not a geography optional is that they might ask you Circuit, Hanging Valley. Okay, Hanging Valley is there in marine landforms also. Okay, Hanging Valley is a part of marine landform also. So Hanging Valley is not just unique to just glacial landforms. The maximum question that you are going to get is Horn and Circuit forms which part of topography or which part of landform. That's the maximum question you are going to get, even if at all UP is going to ask you a question. Here for a general aspirant. Okay, only if you are a geography optional aspirant, then you have to know the in-depth. You have to learn about all these different types and how these are different from the others. Okay, so from the name itself, I hope you can understand that trough means any place that is okay that consists of trough. So glacial trough is basically where the glacier goes. Okay, horn, from the name itself, you can understand. Horn means what? A projected triangle like structure is horn. Okay, this is a erosional topography of glacier, right? Then cirques. Cirques are nothing but a circular like structure which is a trough like circular structure. Okay, a small hole or a small depression on a huge mountain that is called circuit. Okay, this is horn, this is circuit. Then there is something called eriti. Eriti is nothing but horns. If you see in the third three-dimensional horn, okay, horn will look like this. Okay, in the third dimensional, in three-dimensional, and this region of protruding regions on the three sides, okay, or the fourth side on the behind, this is called arete. Nothing but just this protruding region of horn is the arete. Okay, then it is lakes, noster lakes, nothing but lakes created by the melted snow, the melted glaciers in the mountains is the noster lakes. Then ton and the circuits are almost similar. Only thing is the ton is the place where water is situated inside a circuit, that is ton. Okay, so this is the erosional landform. Then depositional landforms. Okay, so this moraines, here it is visible, right? Moraine. Okay, glacial moraines are very important because this is where the important deposition happens. Okay, and different moraines are there: ground moraine, end moraine. Okay, nothing but depending upon the place. Okay, if it is the end of the glacial topography, then it is end moraine. Okay, so different moraines are there depending upon the places. Then there is a feature called drumlin features. So drumlins are nothing but depositional features. Okay. So when glaciers taking the minerals, okay, when glacier is taking minerals and boulders, stones, sand, and it gets deposited in certain places. When this deposition happens, this feature is known as drumlin feature. This drumlin is also known as basket of eggs. Basket of eggs. Simple reason is it looks like eggs. Okay. So each drumlin will look like egg. So the drumlin picture entirely, if you take, it looks like eggs. Okay, basket of eggs. That's why this drumlin feature is also known as basket of eggs topography. Okay, as I said, when it is the end, it is the end moraine. When it is near ground, it is ground moraine. When it is somewhere in the middle, recessional moraine. So depending upon the place, just the name differs. Moraine means simply deposition of glacier. Okay, then comes esker. Esker is a plain region of the glacial depositional feature. Okay, and then outwash plains, then lakes called kettle lakes. Okay, so these are just the lakes created by the deposition of glacier. So just remember the names. The most important is drumlin and moraines. Okay, shall we move forward?
Yes, sir.
Okay, good. So next is marine landforms. So what do you people know about marine areas? Marines, marine,
Water,
huh?
sea water,
Sea water. Okay, good. Then what else? Salt content. Okay. Come on, you already know certain features from marine landforms.
കുറച്ച് കഴിഞ്ഞുണ്ടോ ഡ്രോണി ചിലപ്പോ വന്നെയാണ്
Ocean current.
എന്താ പറ അത് കുറഞ്ഞുള്ളൂ 1 മണിക്കൂർ കൊണ്ട് വണ്ടി സാധനം കൊണ്ട് എടുത്ത് ഉള്ളിൽ വെക്കാൻ
Within
1
your
മണിക്കൂർ
mic is
ഉണ്ടാവില്ല വളവുള്ള പുതിയ ടീമാ
good thing I don't understand what is speaking. Right, anyway. So coming back to marine landforms. So what do you guys know about marine landforms? Certain marine landforms you are already familiar with, right? What are those marine landforms? Delta. Oh, delta comes under fluvial landform, not marine landform, because deltas are not created by marine. It is created by river. Cliff. Okay. So I hope yesterday I said the Kerala coast comes under submergent coast. Am I right? Is that what I said yesterday? Guys, did I say that Kerala coast comes under submergent coast yesterday? West side. Okay. Yes. West side. Okay. Then it is fine. West side of India comes under submerged coast, but not along the entire western region. Okay, only the northern part of western side comes under submerged coast. That is the Konkan coast region. The Govan Konkan coast region comes under submerged coast, whereas Kerala comes under emergent coast. Okay, the Kerala part, only the Kerala part comes under some emergent coast, whereas the northern part, that is the Konkan coast area from Mumbai to Goa, Karnataka, all comes under submergent coast. Okay, a small clarification, because I said, I hope I said the west side, entire west side comes under submergent. It's not the case, only the northern part, whereas southern part comes under emergent coast. Right. So coming back to the marine landforms. So what do you guys know about marine landform? Come on, you already know something. Seawater, cliff. Then the most familiar, right? People of Kerala must be familiar with something, which is the most familiar landform for you related to marine. Good, beach. Yes. Then estuaries. Estuaries. Okay, estuaries can be a form of fluvial landform also, marine landform also, because estuaries are created by the combination of the forces from both the sides. Okay, yes, beach, estuaries, that is the lagoon, backwaters. Okay, all comes under this marine landforms. Good, right? So the most important among them all, this is the erosional landform. Okay, so what you are seeing here is how the erosion happens, and the development of erosion, what kind of, what different kind of topography is created. Okay, so you already know about certain words like abrasion, attrition, right? We saw yesterday itself in fluvial landform, abrasion, attrition, corrosion. Okay, so what happens is the seawater also does that. Abrasion happens, hydraulic pressure will be there. Okay, attrition, corrosion, chemical reaction. With all these things, what happens is a small halo, a hole would be created on a mountain structure, okay, or a huge rock structure that is there in the oceans. Okay, so after certain period, this attrition, corrosion continuously happens for thousands of years together, thereby making the halo even bigger. Okay, first it would be a cave. Okay, first it would be a cave, then it would become a arc. Okay, this is the arc. Then once it continues for some more period, then it becomes a stack. Okay, that is, for example, first it is a rock structure, then in that rock a small cave would be created, then it will become an arc. Okay, and after a certain period, what will happen is even this will get corroded and stack will be formed. And even after a certain period of thousands of years later, the stalks also get eroded, and finally a small bodies, a small stones will be left behind, which is known as stump. Okay, so it's very simple. A huge rock structure, cave is formed, then arc is formed, then stalk is formed, and finally it becomes stump. Okay, shall we move forward? This is the erosional features, erosional landforms. Then one more important thing is the wave cut platform. So these kind of things we cannot see majorly in India. Okay, yes, if you go to the no, the northern coast of northern part of western coast, you can see this wave cut platform in certain regions. Or if you go to Andaman, Nicobar, okay, there you can see some of the places this wave cut platforms. Okay, so the wave cut platforms are not very common in India, right? So simply wave cut platform is nothing but the erosional feature of sea waves. Okay, you know that sea waves come in waves, that's why it is known as waves anyways. So it comes in a series of waves. So what happens is with the series of waves, you know that the force of water would be high in the end, right? That is, the force of the water would be high in the lower regions. Am I right? For example, if you consider this as a plateau region, okay, if water continuously hits, if wave continuously hits this region, then high tide is there, low tide is there. Okay, so according to that, water level will rise, water level will fall. Okay, that is entirely different criterion. Now, when the wave continuously hits this plateau region, it gets corroded. Am I right? Erosion will happen. And if you see this corrosion, concentration will be majorly on the lower side of the plateau because that's where the force is high and that's where the waves will be frequent. Okay, sometimes it will reach to this question, sometimes it will reach to this question, sometimes it will reach to this question. So what happens is a terrace formation will happen. Yesterday itself we saw terrace formation. Am I right? Yesterday itself we saw terrace formation.
Yes, sir.
Yes, sir.
Yes. So here also a terrace-like structure, a terrace-like formation will happen. This is also known as wave cut platform or terrace platform. Okay. So water will intrude, corrosion happens, then little further, then little further, then little further. So what happens is, yeah, platform, wave cut platform like structure or a terrace formation happens. Am I clear? Shall we move forward?
Yes, sir.
Okay. Then hanging valleys. We already saw in glacial landforms, we had hanging valleys, right? So here also we have hanging valley. So simple is, the most simplest thing is, sometimes what happens is the fluvial erosion doesn't match with the retreat of the sea. See, I mean, sea is, you know, that sea retreats sometimes, that is low tide, high tide. Okay. In certain cases, like low tide and the retreat of the sea, what happens is the sea water will go inside. So, further exposing the landmass outside. In those cases, when the fluvial erosion and the retreat of the sea is not matched, some of the regions, that is the cliff regions, you can see a waterfall like structure that is known as hanging valleys. Okay, so this is also a feature of the submergent coast. So cliff, hanging valleys. Okay, almost all of these are the features of submergent coast. Right, shall we move forward?
Yes, sir.
Yes, sir.
Oh, good. Right. Yesterday itself, we saw certain things like rill, gully, ravine, badland topography. Badland topography, also known as wasteland topography. We can say either way, no problem. Okay. So rill, gully, ravine, badland topography or wasteland topography. All these are created by water erosion in arid landforms. Okay, then there are certain features that are created by wind erosion, like mushroom rocks, inselbergs, wind bridges, windows. Then there are depositional arid landforms because of the action of wind only. Okay, example, ripple marks, longitudinal dunes, barchans, parabolic dunes. Okay, so these are the examples of depositional arid landforms. Right. Anyways, so yesterday I said something about rill, right? Rill is a small stream-like structure, a shallow, small stream-like structure that is created when rainfall is happening. Is it visible here? A small, shallow, stream-like structure that is created when rainfall is happening. Is it visible here?
Yes, sir.
Yes, that is rill. And when rill develops, it becomes gully. Okay, then gully to ravine. And finally, a badland topography comes into play. Okay, then we have seen about gorge and canyons, right? Canyons, this is where we saw a terrace formation. For example, the Grand Canyon. Okay, and the gorge is also a structure that is created by water erosion. So these are the features that is created in a arid landform with water erosion. Okay, then this is balsams. Balsams are just a dry region. Okay, a intermountain region between two mountains where it is dry, and this region is known as balsams region. So I hope you people are not familiar with this type of topography. But if you go to southern part of Tamil Nadu, the dry regions like Tirunelveli, okay, there you can see features like this. Okay, then playas. Playas are nothing but temporary lakes. Okay, you know that from time to time in arid region, a small rainfall will happen. With that small rainfall, accumulation of water happens in certain depressed areas, and in those depression, the water lake that was temporarily formed are known as playas. Okay, also known as ephemeral lakes. Okay, ephemeral means short-lived, and playas is a type of ephemeral lakes. Okay, these are just a temporary lake, and over a period of time, you know that arid region, it's known for high temperature. With high temperature, evaporation happens, and this playas is where you can find salt cover. Okay, salt pans. For example, in Rajasthan, Gujarat region, you can find salt pans in playas. So these salt pans are called salinas. Okay. So if you remember playas, it's more than enough. So salinas are just the salt pan, the salt cover left by the playas lake. So these are the other features of arid region. Okay, you know, plateau. Plateau is the tabletop topography. Okay, alluvial fan. When rainfall comes, you know that some deposition will happen, thereby creating alluvial cones or alluvial fans, which we saw already yesterday. Then it is the salt pan playa, which we discussed now. Then it is oasis. You know that wherever depression is there, a huge region of water-like structure, a lake-like structure, would be formed. That is called oasis. And apart from that, barchans. Barchans we will see in depositional landform feature. Barchans are nothing but a type of sand dune. Okay, here it is there, right? A crescent-shaped sand dunes. Barchans are nothing but crescent-shaped sand dunes. You know the shape of the crescent, right? It's the shape of the crescent, right? So crescent-shaped sand dune is known as barchans, or barchans are the crescent-shaped sand dunes. Okay, then it is Inselberg. Okay, so Inselberg is just like a alluvial fan. Only difference is alluvial fan is created by depositional feature, whereas Inselberg is a mountain-like structure which is created by erosion. Okay, then pediment, Utte, Mesa, Vadi. So these are just another features of the arid landforms. Okay, just know the names. It's more than enough. Right. So this is what we discussed, as I already said, wind eroded landforms, certain words like attrition, abrasion. Okay, I already said. So the most important among these features, the mushroom rocks. Okay, so this is one of the most important erosional feature of arid landforms caused by wind. So my question is, if erosion is happening, why erosion is happening only in one part of the region? Why not the entire stone features? Why only in the lower part of the mountain, lower part of the stone? Why? Any idea?
Maybe because it carries sand particles.
Okay, it carries sand particles, but sand particles, it's like evenly distributed, right? With wind, if wind is blowing, sand particles is there in the wind, no matter whether it is in the upper side of the wind or lower side of the wind, it is there. But why this corrosion, this erosion is happening only in the lower part of the rocks, not on the upper part of the rocks? More vulnerable to erosion. The entire rock is made up of the same minerals only. But why the lower part is more vulnerable to erosion? It is more vulnerable, that is true. But why? See, it's not just mushroom rocks. If you see all the features that are given in this picture, Eugen, Yarden, okay, Demotions, all these features, if you see, the upper part is not as corroded as the lower part, right? Even the Geogan, if you see, the upper part is not as corroded as the lower part. Even Demisols, if you see, the upper part is not as corroded as the lower part. Even in Yardum, the same case. Why?
Upper part is very old.
Upper part is very old.
The first formed part, so it will be much older than compared to the lower part.
See, what you are saying is depositional feature. This is not a depositional feature, this is an erosional feature. And also you are telling in reverse. Usually the upper part is the youngest, the lower part is the oldest. High pressure to low pressure area. Anything else? Close to surface. Good, Gokul. It is close to surface. This is created by surface wind, right? So the region that are close to the surface are the one that is usually eroded easily, rather than the one that are further away from the surface, right? And also one more thing is cold winds. Okay, certain regions have cold winds. Cold winds are usually dense in nature. If winds are dense, that means it will sink, which means it will flow near the surface. So what happens is only the lower part of the rocks get eroded, whereas leaving the upper part, thereby creating features like mushroom rocks and geogan. Am I clear?
Yes, sir.
Right. So this is Inselberg. I said right. It is created by a single, somewhere out of the blue, only one single huge rock will be standing. This monod knock is known as Inselberg. Okay. So if you see the entire region surrounding, there would be nothing. Somewhere in the middle, okay, alone, this would be standing. This is the Inselberg or monod knock. Then wind bridges and windows. Just like how sea waves creates caves and then cliffs, okay, arcs. This is also like that, but it is created by wind. Okay, a small hole would be created, then this hole becomes big, then arc is created. So the wind bridges are windows in the. So people who watch Hollywood movies, you might be aware of this one, right? A lot of shots are taken in this wind bridges like region. How many of you watched this movie? Oh shit, I forgot the movie name. Man. The post-apocalyptic movie. There is one famous post-apocalyptic movie, right? I forgot the
Well,
name.
you're asking about 300 or Gladiator?
No, no, no. Post-apocalyptic, I'm asking.
Okay, okay.
Post-apocalyptic means
2012.
some disease or something that destroyed the entire world. After that, a new civilization, new form of civilization is coming. That kind of movie. I think Road Fury.
Yeah, Mad Max, Mad Max.
Yes, Mad Max Road Fury. Okay.
Okay.
So
Yeah, I
if
got
you
you.
watch this movie, you might be aware of this one, wind bridges and windows, right?
Yes, sir.
Yes. Okay. So now, depositional landforms of arid regions. One is ripple marks. There is nothing to explain about this ripple marks. I hope you can see from the picture itself. A ripple mark is nothing but deposition of the whatever it collected from mushroom rock, whatever it collected from other regions, it just disperse it in this region, thereby creating ripple marks, uneven ripple marks. Okay, so this one. Next is sand dunes. Sand dunes are depositional landforms, as I already said. Different sand dunes are there. One is Barkans. It doesn't matter. You can, it's your pronunciation. Okay. So Barkans are nothing but crescent-shaped dunes. Okay. It is a type of longitudinal dune, right? So again, same concept, longitudinal and transverse. What is the difference? What is the difference between a longitudinal and a transverse? What is the difference between longitudinal and transverse? Simple. Okay. So if a dune is created parallel to the flow of the wind, that is called longitudinal dune. Okay. If a dune is created parallel to the flow of the wind, that is called what? Longitudinal.
Transversal.
Okay. If it is created perpendicular to the flow of the air, then it is called transverse dune. Okay, so which means longitudinal dunes, okay, like barchans are created parallel to the flow of wind. For example, if wind is flowing on this side, barchans would be created on that side. Wind is flowing this side, right? Barchans are created. Wind is flowing this side, barchans are created. Okay, so parallel to the flow of the wind, if a dune is created, that is called barchans. Sorry, that is a longitudinal dune. Barchans are a type of longitudinal dune, okay, which are crescent shaped. There are different longitudinal dunes are available. Barchans is one such type which is crescent shaped. That's the only difference. And transverse dunes, which are created perpendicular to the direction of flow of wind, which means if wind is flowing on this side, if a dune is created like this, that means it is perpendicular to the flow of wind. Since it is perpendicular to the flow of wind, it is called as transverse dunes. Right? Am I clear?
Clear, sir.
Okay. And parabolic dunes, simple. both varchans and parabolic are longitudinal only. Only difference is parabolic means it's a shape, right? That's the difference. Then Louis are a very important feature. I hope you remember that in China, when we are speaking about, I mean, when we're discussing China map, I told something about Louis, right? Do you remember? No? No idea? Okay, so at least do you remember that the northern part of China comes under desert region? Do you remember at least that? At least that much?
Yes, sir.
Yes, sir.
Yes, good. So wherever deserts are there, okay, if from the desert region, okay, you know that this Manchurian region, okay, this north western part of China all comes under desert and grassland type. Okay, so wherever desert is there, okay, if the materials from the deserts are collected by the wind and when it travels a long distance, okay, what happens is the heavier material settles first. Okay, see, wind will lose its velocity at one point of time, right? Its force and velocity will get reduced as the distance it travels. Okay, for example, if there is a cyclone in right, if there is a cyclone in which place I should say, okay, if there is a cyclone in Calicut, then people of Kannur, they should not feel the uh, cyclone, right? Maybe they might feel wind with high velocity. Okay, little high velocity of wind they might feel, but they won't feel the cyclone. Just like that, when wind travels from one region to another region over a long distance, what happens is it loses its velocity. So when it starts to lose velocity, what happens is heavier materials that are collected by the wind gets deposited, thereby creating dunes. Okay, we have seen different types of sand dunes. Dunes are created. And furthermore, it travels, what happens is it collects only finer particles. Okay, the finer particles, fine like so fine, okay, very fine. These fine particles, what happens is when it travels long distance and settled in one place, that is called Lewis. Okay, the finer particles carried by the wind for a long distance, okay, and settles in one place, that is called Lewis. Okay, so this Lewis you can see in China, and the beauty of the Lewis is Lewis are very nutrient rich minerals. Lewis are nutrient rich soils, so it becomes one of the most agriculturally productive regions of the world. Okay, am I clear?
Yes, sir.
Good. Next is karst topography or karst landform. Simple, karst is just a region. Okay, karst region is the region that you can see in Yugoslavia. Okay, near the Adriatic Sea. The speciality about this region is it is made up of limestone. Right? What is a limestone? Is it a soft stone or a hard stone? Is it a sedimentary or an igneous? Is it sedimentary or igneous? Is it soft or hard? Sedimentary, soft, right? So, limestone region, the limestone topography is also, the karst topography is also known as limestone topography. Okay, and simple, basically it is eroded by water, by the action of water. Okay, both by chemical action as well as physical action. So basically, a karst landform or a karst topography is a limestone topography, a limestone region that is corroded and eroded by the action of water. That is what a karst topography is. Right? Am I clear?
Yes, sir.
Okay, good. So this is a limestone bed. Okay, what happens is river is there. Okay, water is there. It continuously flows on the limestone topography, and at one point it will find a small fault, a weakness in the limestone region. For example, this region. For example, this region. For example, this region. For example, this region. So a weak spot, okay, a weak spot would be found by the river. So this weak spot is known as sinkholes. Okay, this weak spot is known as sinkholes. What happens is, since there is a weak spot, water enters into the ground through this sinkhole, and water starts to flow inside the limestone region, thereby creating caves. And over a period of time, stalactite, stalagmite would be created, and finally, this topography entirely gets destroyed by the eroded water. Okay, so this is an example of a cavern or also a cave that is formed by the limestone topography. Okay, this is nothing but the action of water in a limestone region. This is how a cave is created. Okay, then the most important of the feature is stalactite and stalagmite. So this one, I hope you people might be aware of this, right? Have you seen this feature?
Yes, sir.
Have you seen
Yes,
this
sir.
feature? Yes.
Yes, sir. Seen it.
In different places you could have seen. Okay, wherever dripping water is there, okay, there you can see these features. And especially if the stone is soft, you can wonderfully see these features there. Okay, so this is nothing but water drips continuously. Okay, this dripping water, what happens is the down region, this dripping water gets accumulated, thereby creating a feature called stalagmite. Okay, the dripping water on the top region, it creates another feature called stalactite. Okay, over a period of time, what happens is the erosion on this place and the deposition at the other place, due to the dripping water, it becomes a pillar over a period of time. Okay, a pillar like structure will be created because of the dripping water. Okay, so this is what stalactite and stalagmite is. Right? Am I clear? Shall we move forward?
Yes, sir.
Right?
Yes, sir.
Okay, good. So what you guys do is, first you write one answer for plate tectonics. Okay, then we'll move on to oceanography. Okay, before moving to oceanography, you just write one answer for a plate tectonics related question. Okay, shall I give you the question?
Yes, sir.
Sir.
Okay. Okay. So the question is, with reference to the theory of, with reference to the theory of, with reference to the theory of plate tectonics, with reference to the theory of plate tectonics, explain the origin, explain the origin and growth of, explain the origin and growth of young fold mountains. With reference to the theory of plate tectonics, explain the origin and growth of young fold mountains. Right? Am I clear?
Yes, sir.
Okay, good. Right, so you guys take 10 minutes and write answer for this question. Guys,
Yes, sir.
done right?
Yes.
What is the introduction?
Sir.
Yes, what is the introduction?
Sir, I think it would be better to write who formulated the theory and from which all theories this plate tectonics theory was inspired from.
Hmm.
I think the definition part, I think we can write it in the content section.
Okay. Then first tell me the introduction and conclusion.
Sir, we can write introduction as like the theory of plate tectonics was inspired from
Hmm.
continental drift theory, convection current theory, and theory of seafloor
Good.
spreading.
Hmm.
And also we can write that it was suggested by two person, that is Mackenzie and Parker.
Good. Hmm.
That's all about the introduction.
Okay, good.
And I
So
think the theory, the explanation of theory, I think we can write it in the main content section.
okay, okay, good. Hmm. Then what else? What is the conclusion?
But sir, can we say that by referring this theory, we can find the age of mountain like that?
Not getting what?
Can we say that by referring to this theory, we can find the age of mountains, etc.?
Age of mountains.
Yeah.
Not directly actually.
Okay.
Age of the mountains has got nothing to
Okay.
do with the theory, but the theory explains why certain mountains are formed at certain regions. That you can explain with the theory, but not the age as such.
Okay, sir. Okay.
Hmm. Then guys, come on. This is one of the most important theory. I told you, this is where if at all UPSC is going to ask a question related to geomorphology, they are going to ask you directly from this place only, continental drift theory, plate tectonics. Okay, this is where the UPSC concentration is going to be. If at all there is a question from geomorphology comes. But for the past 10 years, there's hardly any question from geomorphology. And even if that is the case, as I said, it's here where UPSC is concentrating. Apart from that, it is oceanography and climatology, where UPSC is asking questions from. Conclusion helps to understand how different landforms are formed by plate tectonics. Okay. Right, you should mention the convergence of the plates. Okay, conversion of continent plates and how it is creating faulting, folding, warping. You have to mention all these things. You have to draw diagrams. You have to draw the Youngfold mountain regions. You just simply draw an India map and you can mark the Himalayan region, Youngfold mountain, or the entire world map you can draw and show where Youngfold mountains are there. You can do that. Only by doing all these things you will get good marks. Otherwise, it's difficult, guys. Kindly keep this in mind.
Sir, that all comes in the content section, no?
Yes, content section only.
Okay.
Content only I'm saying now. For the content, you have to write all these things. You have to provide the continent convergence. You have to tell the different plate boundary movements are there, and the Youngfold mountains are created in the boundary of convergent, where the mountain building process is happening, how subduction is happening. Okay, all these things you have to say and provide an example with the Indian plate, with Eurasian plate, and the Himalaya, and again Switzerland. Okay, so you have to draw diagrams, 3-4 diagrams. You have to provide examples. You have to provide the exact mechanism, right? First, just provide plate tectonics, the explanation for plate tectonics, right? Then anything else? Shall we move forward?
Yes, sir.
Yes, sir.
Okay, good. So now we'll dive into oceanography. Okay, just we'll mention certain reliefs, then you guys can take break. Okay, there's no hurry in it. Slides are visible, right?
Yes, sir.
Visible?
Visible.
Okay. Right. Okay. So ocean relief feature. Okay. So before going into oceanography, that is, in oceanography, will be seeing ocean currents, salinity, temperature. Okay, and apart from that, tides. So these are the major 3 topics from where UPSC asking question, and especially related to oceanography. Ocean current is the most important of all. Okay, the tides and all, no problem. That is majorly UPSC prelims related questions. The most important part where you have to concentrate is the ocean current. Okay, so I hope today we'll complete ocean current anyways. If at all there is any time left, we will see other regions such as salinity, temperature, and tides. Those will take hardly some time. Okay, right, anyway. So before going into that, you have to know certain relief features of oceans. And I hope you already know certain relief features of oceans, right? What are those relief features which you guys already know? certain oceanic features which you guys already know. What are those features? Good. Trenches. How are trenches created? Ananta? How are trenches created? Subduction of plate. Okay, good. So the trenches are created near convergent plate or divergent plate? Convergent or divergent plate? Convergent plate. It is in ocean-ocean convergence or it is ocean-continent convergence? Ocean continent. Okay. Are you sure it is ocean continent, not ocean-ocean? Okay, right. Anyways, we'll see. Right. So the ocean relief, you guys already aware of certain things. For example, mid-oceanic ridges. Okay, what is a mid-oceanic ridge? What is a mid-oceanic ridge? Guys, are you there? Underwater mountains. Mid-oceanic ridge is not an underwater mountain. Magma eruption. Divergent plate boundary. Good. So the majority of the ocean reliefs, okay, are created by tectonic process, the plate tectonics. That's why, again, even in oceanography, plate tectonics plays a major role because the entire relief of oceans, you have answer in plate tectonics only. Okay, just like how mountain systems are created by by the help of the plate tectonics theory, you can understand how mountain systems are created. Ocean relief creation also answer lies in plate tectonics only. So if you just change the question into ocean relief features, you can write answer. Okay, the question just you have to change instead of mountain ranges, instead of young-fold mountains, if you change ocean relief, then also the question is valid. Okay, this is what I said. If you know plate tectonics, if you once know plate tectonics, you will know about volcanic features. Okay, the volcanic activities. You will understand mountain building process. You will understand ocean relief features. Okay, plate tectonics has answer for all these processes, including earthquake. Okay, so the concept is same. That is plate tectonics. Only what we are going to see, or only what we are going to understand plate tectonics, or what we are going to learn different features related to plate tectonics. That is different. Okay, so ocean relief is one such feature, tectonic and volcanic, erosional and depositional process and their interaction, obviously. Okay, again, exogenic and endogenic. And here in this case, exogenic means erosion and depositional feature that are created by the sea waves and the movement of the sea. Okay, whereas tectonic and volcanic are the endogenic geomorphic process in this case. Okay, so major and minor ocean relief features are there. Okay, So four major divisions of ocean relief is major relief is one is continental shelf, the other one is slope, the other one is rise, and finally deep sea plain or the abyssal plains. Okay, simple as that. Shelf, slope, rise, and deep sea plain or the abyssal plains. So if you consider shelf, slope, rise, okay, right. So right, if you consider this to be the ocean region, okay, right, considering this to be the ocean region, the first in contact is the continental shelf, okay, then it is slope, okay, then it is rise, and finally this region, okay, where it becomes plain and undulating plain, that region is the deep sea plain or abyssal plain. Okay, so this is nothing but, if you draw a diagram, it's shelf, slope, rise, and after that it is abyssal plains. Okay, so then minor relief features are there. So minor relief features like mid-oceanic ridges, okay, hills inside the sea floor, sea mounds inside the sea floor, goyots inside the sea floor, trenches inside the sea floor, canyons inside the sea floor, sleeps, fracture zones, island, atolls, coral, submerged volcano, sea scarps, all are the minor relief features of the ocean. Okay, so what you guys do is you guys go for break and come back. Okay, so then we'll see the major relief and minor relief features. Okay,
Okay, sir.
right. Hello, guys.
Yes, sir.
Right. So major and minor ocean relief features. So these are the major and certain minor relief features, including. Okay. So what you are seeing here is the continental shelf region. Okay. So both in submergent and the emergent coasts, this continental shelf can be seen, but only in the emergent coast, the continental shelf would be much broader. Okay, for example, the Tamil Nadu coast, if you see, it comes under emergent coast. Okay, it is broader, right? It is broader in nature, and it's not favorable for navigation purposes. Okay, submergent coasts are more favorable for navigation and even the fisheries, whereas the continental shelf is not favorable for such features. Okay, so once the continental shelf region, okay, like a cliff-like structure comes in, that is the region for continental slope, right? Shelf is an extended region of the land where water is shallow, and when slope hits a sudden drop in the altitude, you can see a sudden drop in the slope or sudden increase in the steepness of the slope, you can see that is where the continental slope is. Okay, and near the end of the continental slope is where the continental rise lies. Okay, shelf, then it is slope, and when the slope is near to the end of the abyssal plain, that is called rise. So from coastal region towards the ocean, if you see, it is shelf, then slope, then rise. From ocean to continent, if you see, it is rise, then slope, then shelf. Okay, so UPSC never asked this question, but in test series you will recurrently find these kind of questions. The arrangement from ocean to continent, continent to ocean. Okay, so this one, and then volcanic islands, which you already aware of. Okay, volcanic islands, then mid-oceanic ridge, which we discussed a lot of times. Then it is trenches. This is called trenches. So Anantu, now tell me, trenches, whether they are from happens near continent or continent ocean. Sorry, continent ocean or ocean. Trenches. Continent ocean. Okay. Right. So this is what the continental rise looks like. Right. I told you first it is the shelf, the extended region. The extended region is the shelf region. Then the slope region is known as the continental slope. Okay, and near the end of the continental slope is the continental rise region, which leads to the abyssal plains. So it is shelf, then slope, then rise, then abyssal plain. From ocean to continent, it is plain, then rise, then slope, then shelf. Okay. So as I said, the continental slope gradually loses its steepness with depth. So when the slope reaches a level of 0.5 degree to 1 degree angle, then the continental rise comes into. Okay, as I said, the end of the continental slope, where the slope decreases, that's where the abyssal rise occurs. Okay, so this is the abyssal hills, or also known as abyssal plains. So this is the region of abyssal plain, undulating region. Okay, from the name itself, I hope you can understand. Plain means, abyssal plain means an undulating feature. Okay, so here you can see certain features like sea mount. Simple, a mountain under the sea is a sea mount. Then volcanic islands. Volcanic island is basically an island formed because of volcanic eruption. Then erosion. Okay, with erosion, what happens is a guyot is formed. A guyot is nothing but a sea mount or a volcanic island eroded because of the action of the sea is known as a guyot. Okay, simple, a sea mount or a volcanic island which eroded because of the action of the sea is a guyot, or a guyot is a tabletop sea mount. Okay, then the most important of the surface, near surface features like atoll. Okay, I hope you know about atoll, right? What is an atoll? What is an atoll? What is an atoll? What is an atoll, guys?
Don't know, sir.
Okay, no problem. So atoll is nothing but a feature created by corals. Okay, a feature created by coral is atoll. Only difference is an atoll is a kind of circular shaped coral reef. Okay, as you see in this picture, it is a circular shaped coral region. Okay, this is what an atoll is. Different kind of reefs are there, coral reefs are there. Okay, barrier reef, one type, for example, the Australian barrier reef, then atoll reef, then fringe reef. Okay, so different types of reefs are there depending upon their structure. So basically, atoll is a coral reef formed in a shallow region of the shape is round shaped. A circular shaped coral reef feature is atoll. Am I clear? So generally, where it appears is there could be a depression, as you see in this picture. This is a depression. Okay, here the water is deep. Okay, see, there are certain criteria for coral formation. One of the important criteria is the water should be shallow. Okay, water should be shallow. What is shallow means? What does shallow means? Shallow. Guys, what is shallow? Less deep. The deep, less deep. Okay, wherever depth is low, that is called shallow, right? So, if you see this region in this picture, you can see that the surrounding areas are shallow, whereas here it is deep. As I said, for coral reefs to grow, it needs shallow water. That's why you can see coral reefs in continental shelf region, not in other parts. Okay, if you see the Australia, the continental shelf is broad. Okay, so in India, where can we see coral reefs? In India, which region can we see coral reefs?
Lakshadweep.
Lakshadweep, Andaman Nicobar. Yes, Andaman Nicobar is the only place where you can see all three different types coral reefs. You can see mangrove forest. You can see tropical rainforest also. Andaman Nicobar is the only place where you can see this. Okay, Gulf of Kutch is a great example for coral reefs. Okay, Gulf of Kutch, Gulf of Mannar. Okay, because as I said, emergent coasts where the continental shelf is broad, okay, their waters are shallow. In those places, you can find corals, okay, whereas in estuaries, you cannot find corals. In deltas, you cannot find corals. The reason is deltas and estuaries are one of the most polluted regions. Okay, not just pollution in the sense, I'm not speaking about the pollutions created by anthropogenic activities. Also, the pollution, the minerals that are brought by the river, the depositions that are created by river also creates a disturbances in the sea. A disturbances in the sense makes the water muddy. So the muddy water is not a favorable region for corals to grow. So a broad continental shelf where water is shallow and the temperatures are around 25 to 30 degrees Celsius. That's where the best suited place for a coral reef. Bright sunshine is needed. Okay, temperature should be 25 to 30 degrees Celsius, right? Shallow water of broad continental shelf, all these things are needed, and that is why Gulf of region and Gulf of Kutch and Gulf of Mannar region are those places where emergent coast is there, where continental shelf is broad in nature. Those are the places where you can see coral reefs. Okay, so basically atoll is formed because atoll is in round shape because the center region is depression region where it is water is in a deep depth. Okay, so the surrounding areas where water is shallow, that's where coral reefs grow, and that's why the shape is circular. Right? So I hope you learn more about coral reefs, their favorable conditions, unfavorable conditions in environment. Okay. So right now in geography, this is enough for you. Okay. Then it is bank, shoal, and reef. So reef, you already know. Reef is the coral reefs. Okay. What is a bank? What is a bank? River bank, M bank. What is a bank? Shore. Yeah, simple as that. Okay, so bank, shoal, reef are the near coastal places. Okay, near coastal related features. So this has got nothing to do with the deep ocean like seamoon, guyards, nothing. So bank, shoal, and reefs are those features created by the activities of waves, and the near surface or the near continent features. Okay. Right? Then ocean movements. So the most important ocean movement is ocean current. Okay, so when we speak about ocean movements, the three most important movements of ocean is that one is waves, okay, which we already know. One is waves, the other one is tides, the other one is currents. Okay, so I hope you know how our waves are formed. Why waves are formed? How, what is the force, what is the driving force for the waves? How, guys? Wind, okay, simple as that. Due to wind. The friction that is created by moving wind on the surface water is how waves are created. Okay. And the second one is tides. As I already said, tides are created by the gravitational pull of moon and earth. Okay. Along with the force that is created by the earth. Is it centripetal or centrifugal?
Centrifugal.
Centrifugal. Okay, let's see. When we are discussing about tides, let us see whether it is centrifugal or centripetal. So right now we'll concentrate on this one. So if you see the ocean movements, the most important one is ocean currents. Waves are created by the friction, and tides are created by the gravitational pull. And how are ocean currents created? Okay, waves, wind, okay, tides, gravitational pull, okay. Then how currents are created? Ocean currents. What is the driving force for current? What is ocean current? First of all, temperature difference. Okay. Temperature difference, density. Okay. What you are saying is the movement of ocean currents. Temperature difference causes the movement of ocean current. It influences the ocean current, but how ocean currents are created? What is the force that creates ocean current? Right? What is the force behind the ocean current? Guys, what is the force behind ocean current? Am I audible?
Yes, sir.
Okay, tell me, what is the force that creates ocean current?
So
There should be a force, right?
maybe due to salinity difference.
Due to salinity difference, okay, but that's what I said. Salinity, temperature, or all influences ocean current. But there should be a force that creates ocean current, right?
So rotation of Earth.
Rotation of Earth. Okay. Yes, that you can see. So which force is created by the rotation of Earth? What is the force that creates rotation of Earth? Is the screen visible? I mean, slides visible, whether the slides are...
No, sir.
No, sir.
Just a minute. Is it visible now?
Yes, sir.
Okay, then fine. Yes. So tell me. See, ocean current has basically two types of forces are the forces that creates and influences ocean current. Okay, so ocean current, you cannot say a single reason. For example, you cannot say just temperature, you cannot say just salinity, Yes, temperature influences the movement of ocean current, right? Yes, salinity influences the movement of ocean current. Density influences the movement of ocean current. But the creating force, okay, there is no single force for the creation of ocean current. Multiple reasons are there, multiple forces are there behind the creation of ocean currents. Okay, but anyways, just like any other thing in the world, any other thing in the globe, the important reason is the source of the sun, right? The source of the sun is the source for all the changes that is happening in the globe. So here also sun plays the major role. Okay, so if you see the ocean current, they are influenced by two types of forces. One is the primary, the other one is the secondary. Okay, so primary forces are the forces that initiates the movement of water, that is the ocean current. So now tell me, ocean current, whether this happens in the surface level or whether it happens at the deeper level, surface or deep levels?
Surface.
Surface level, okay. Are you sure surface?
Sir, I have read the definition in
Surface and
NCRT.
subsurface. Okay. Right, anyways. We'll see the forces. Once you see the forces, you will understand. The primary forces that influence the current, as I said, the solar energy. First is the solar energy. Second, wind, gravity, Coriolis force. So, what is Coriolis force? What is Coriolis force? What is Coriolis force?
Force resulted as the result of rotation of Earth.
Simple, right? So, rotation of the earth creates this Coriolis force. Okay, so the secondary forces are the temperature difference and salinity difference, or those features which influences the movement of ocean currents. So the initiation is because of solar energy, wind, gravity, Coriolis force. As I said, there's no one single force or one single reason. There are multiple forces available, and then secondary sources are those sources which influences the movement of ocean current. First is the insolation or the incoming solar radiation. So thinking about the incoming solar radiation, I hope you know that near equator, the temperature is high, right? The temperature is high near the equator. Why? Why the temperature is high near equator? Come on, guys, we already saw this one. Why?
Closer to the sun.
Closer to the sun. Direct sun rays,
Sunlight.
shape
Yeah.
of the earth. Okay, right, good. So because of this, what happens is, you know that water absorbs heat. By observing heat, water expands. Am I right? This is how it is. So what happens is the expansion of water near the equator creates a gradient. For example, if you consider this to be the globe and this to be the water above the globe, okay, near the equator, what happens is the absorption of heat creates upwelling or swelling of the water, okay, thereby creating a slope, right? It creates a gradient, it creates a slope. So what happens is the water from the equatorial region, it slowly moves towards the other regions, other sites. Am I clear?
Yes, sir.
Okay, good. And also it usually moves from west as a east to west. Why? Why east to west? Why not west to east? Why
Trade
east to
winds.
west? Huh?
Trade winds.
Trade winds are trade winds, different directions are there, right?
Sir, trade winds are the permanent winds, no?
Yes, trade winds are permanent winds.
Okay.
Why? Why east to west? Okay, we'll see. Right? Then winds. So you know that wind helps in the movement of water. Okay, so wind also helps the movement of ocean current, the surface ocean current, because you know that friction created by wind helps in the movement. Okay, and Coriolis force also affects the direction, right? Then monsoon winds, for example, then oceanic circulation. So as I said, so many forces are in play. Okay, since so many forces are in play, you have to understand about how different forces acts differently on the ocean current or the ocean circulation. Okay, so I hope you know that Coriolis force is the force created by the rotation of the earth, and Coriolis force deflects the wind that is on the surface. Am I right?
Right, sir.
Yes. This is globe. Consider. Okay, this is to be the equatorial region. You know that world rotates from west to east. Considering that, okay, if you consider that, that means if ocean current flows, which side should it flow? This side or this side? Which side? From west to east or from east to west? Considering the circulation, considering the deflection. Which side, guys? Which side should it flow? East to the west. Right? So, since globe is rotating from west to east, okay, the water movement is from east to west. Okay, so what happens is in the northern hemisphere, it takes clockwise rotation. Okay, to consider this, it takes clockwise direction. The deflection of Coriolis force creates clockwise rotation in the northern hemisphere and anti-clockwise rotation in the southern hemisphere. Am I clear?
Yes, sir.
Clockwise, whereas here it is anti-clockwise. Okay, then wind pattern, that is the atmospheric circulation or the pressure belt. So this we will see in climatology, where we'll discuss about different pressure belts. Okay, once you understand that the pressure belt, and after seeing or after discussing the pressure belt, what you guys should do is you come back again, once again revise the this ocean current. Okay, then you will understand more, then you will understand deeper. Okay, so right now just understand there is something called atmospheric circulation or pressure belt circulation on the wind. Okay, so the pressure belt circulation differs in different region. Okay, for example, in higher latitudinal region, that is around 50 degree north, okay, or 45 degree north, or even 60 degree north, at higher altitude region, sorry, higher latitude region, what happens is the wind flow is cyclonic in nature. Cyclonic in nature means the warm and cold meets together. Okay, in higher latitudinal region, warm and cold currents meets together. Do you remember a warm and cold current meeting near the coast of Labrador and Newfoundland?
Yes, sir.
Yes, a Labrador current and Gulf
Gulf
Stream,
Stream.
right? So this is how the wind influences atmospheric circulation. So how exactly the wind influences? The wind takes the region of warm current, okay, it makes the warm current travel towards the colder region, and the cold region, from where the cold currents originates, the wind makes them travel towards the warm region. So what happens is the warm current and cold current meet somewhere in the middle. Am I clear? So warm current obviously originates near the equatorial region, right? This is the equatorial region. Warm current originates here in equatorial region. This is the colder region. Cold current originates in the colder region. So what happens is cold current travels towards warm current and warm current travel towards cold current. This is how the wind circulation or the wind pattern or the pressure belt pattern of the earth influences the movement of ocean current. Is it clear now? Am I clear?
Yes, sir.
And why wind is moving from this region to this region, that is from cold region to warm region, and why wind here is moving from warm region to cold region, that we will see in pressure belt maybe tomorrow. Okay, the most possibly tomorrow, right? So just right now understand that warm current moves towards cold current and cold current moves towards warm current. If you understand that much, it is enough, right? Then gravity. So you know about gravity, right? Gravity extends a pull pressure, right? Because of the pulling of gravity, what happens is one area it is less gravity, one area it is high gravity, right? If you consider polar region and equatorial region, where can you see high gravity and where it is low gravity? Poles high gravity and equatorial region low gravity. You already know the reason why it is, right? From the center of the earth, the distance between the equator and the center of the earth is more, considering the distance between the center of the earth and the polar region, because of the shape of the earth, that is geoid or bulge in the center. So since distance is high, here gravity is low. Since distance is low, here gravity is high, which means a gradient is created in such a way wherever gravity is low, water can move freely. Wherever gravity is high, water sinks. So what happens is, due to the gradient of sinking near the polar region and expansion, already expansion is there in the equatorial region. Now, apart from the expansion, low gravity also helps the water movement in such a way from warm region to cold region. So this is how gravity influences the gradient variation of water pattern, right? Am I clear? Then influence of the Coriolis force. So Coriolis force always reflects or deflects the wind in the right hand direction in northern hemisphere and left hand direction in the southern hemisphere. Okay, am I clear? Coriolis force deflects wind in the northern hemisphere towards right hand direction, in the southern hemisphere towards the left hand direction. Okay, this is common to Coriolis force, even in oceanography, even in climatology, even in pressure belt. When we are going to discuss, Coriolis force acts in such a way that in northern hemisphere it is right hand, In southern hemisphere, it is left hand. Am I clear?
Clear, sir.
Okay, good. As I already said, if you draw a simple diagram, you will understand. Right? From east to the west, both the sides, right? This is how it deflects east to the west. Am I right? This is what we saw here, from east to left, because of the rotation of the earth. Since the rotation is west to east, the deflection is from east to west. Am I clear?
Yes, sir.
Okay, if that is the case, this one is left hand direction, okay, accepted. This one should be right hand direction, right? Then why it is also in left hand direction? I said that in southern hemisphere it deflects left, which is understandable, because if you draw a diagram and mark the Coriolis force, it acts the opposite direction. Since earth rotates west to east, it goes from east to west, right? This one is left hand direction, yes, understandable. And this is also in left hand direction, right? But I'm saying right hand. Why or how? Good, Biju. So basically, if you say right hand direction, you should be an observer who is standing in the northern hemisphere. Okay, we are seeing this in standing in the southern hemisphere. If you are standing here in the southern hemisphere, this is left hand direction for you. If you are standing in the northern hemisphere, then this is right hand for you. Here it is left hand, here it is right hand. Am I clear? So the point of reference is very important. If you are standing in northern hemisphere, then this becomes your right hand. If you are standing in the southern hemisphere, then this becomes your left hand direction. Am I clear? Is it clear? Because this, if you understand this concept, it will be very helpful and it will come handy in climatology also. That is when we see pressure belt. Is it clear, guys? Shall we move forward?
Yes, sir.
Okay. And also I said clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere, which means since it is right hand here, it goes in clockwise direction. Since it is left hand here, it goes in anti-clockwise direction here. This is common to not just ocean current, but also wind circulation pattern, but also cyclone formation. Okay, even cyclone forms in such a way, it is different in northern hemisphere and it is different in southern hemisphere. Okay, this clockwise and anti-clockwise movement. Right, now coming to secondary forces that are responsible for the movement of ocean currents. So we already know one is the temperature difference, the other one is the salinity difference. So how come temperature affects the movement of ocean current? How come temperature affects the movement of ocean current? Guys, what happened to you all? Are you all sleeping?
No, sir.
Then please tell me, Arjun. Right, okay. Now tell me, which water is dense in nature, whether it is cold water or warm water?
So warm water.
Warm water. Why? Warm water has less density because warm water warm water expands. When water is warm, when you heat water, it expands. Am I right? When it expands, that means density is low.
Yes,
Right?
sir.
So once it expands, water density decreases. Right? Okay. Cold water. Okay. Exact opposite. Since it is cold, what happens is density is high. Now tell me something. If cold water density is high, then I should not float on water, right? I should sink on water. If you put ice cube, it should sink in water. Then why ice cubes are floating in water if cold water is dense? You understand my question, right? If cold water is dense, then ice cubes should sink in water. But ice cubes are floating in water, right? Why? Denser than warm water. You understand my question, right? You understand my question? Salinity is a reason to float Dead Sea. That is entirely different concept, Arjun. I'm not asking about saline water or saline ice cube. I'm just asking about simple ice cube. If cold water is dense, that means if you put ice cube, it should sink. Why it is not sinking? For that, you should understand one more concept. Cold water is densest when it is at 4 degrees Celsius. Okay? Cold water is densest when it is 4 degrees Celsius temperature. If it goes below 4 degrees Celsius, it changes into ice. Once it changes into ice, the property becomes different. That is, ice becomes less dense. I mean, ice is less dense or less, yes, ice becomes less dense when you compare it with the water. Okay, ice is no more liquid, ice is solid. Okay, since the properties are changed, the other properties like density also is changed. Since the state of matter is changed, the properties of the matter also changed. Am I clear? This
Yes,
is
sir.
why
Clear.
ice floats on water, whereas cold water sinks. So what happens is, you know that near equatorial region, water is less dense, so expansion happens, less dense the water is. So hot water, or sorry, the warm water floats on the cold water. Whereas near polar region, the water is cold, which means it's dense in nature, so water sinks. Am I clear?
Yes, sir. Clear.
So in the polar region, water is dense, so water sinks. In the equatorial region, water is less dense. So what happens? Water floats near the equatorial region. Again, this creates a gradient. That is, The warm water floats on the cold water and moves towards the colder region. The cold water sinks down and moves towards the warm region. Is it clear? Is it clear, guys?
Clear, sir. Clear.
Okay, good. Then again, salinity also. If water is more saline, that means it is high density. If water is less saline, it means low density because of the presence of minerals. Okay, again, wherever water is high salinity, wherever water has high salinity, water sinks. Wherever water has low salinity, water expands and floats on the high saline water. So now you tell me which region has low density of water, high salinity, and which region has low salinity? Is it near the equator high salinity? Because temperature is high. If temperature is high, evaporation is high. If temperature and evaporation is high, that means water evaporates, whereas salt stays, which makes the water high saline in nature. So equator should be the place where high salinity is noted. Am I right?
I thought like that, sir.
Okay. What about other people? What do you think, guys? Anantu, what do you think? Anjana, Biju, what do you people think? Okay. But that is not the case. Yes, equatorial region has high temperature. Yes, high evaporation is noted near equatorial region. But one more thing you are forgetting is that equatorial regions are known for rainfall, high rainfall areas of the world. The entire equatorial belt, as I said, every day cloud formation, precipitation. Air mass rise, cloud formation, precipitation. Air mass rise, cloud formation, precipitation. That's what happens every day in equatorial region, which means even though high evaporation rate is there, even though high temperature is noted, new water is added to the ocean in form of rainfall, as well as water from the rivers, Amazon rainforest, Nile, Congo, Indonesia. Okay, all the important river systems of the world are near equator, so new water is added into the ocean from time to time. So what happens is, in equatorial region are not those regions where high salinity is noted. Instead of that, tropical regions near the Tropic of Cancer is where high salinity regions are noted. Okay, around Tropic of Cancer, around 30-degree north latitudes, from 25 to 30-degree north latitudes, this region, you can find high salinity. So where is Dead Sea, guys? Someone said about Dead Sea, right? Where is Dead Sea? At which degree latitude?
Jordan,
Jordan, right? Which degree latitude?
I don't know, sir.
Okay, no problem. Same only, 25 to 30-degree latitudes. So if you take the highest salinity noted regions of the world, all of them are situated around 25 to 30-degree north latitudes. Okay, south also same case, right? Am I clear? So this is how salinity affects, and this is the reason for high salinity in some places and low salinity in some places. Am I clear? Shall we move forward?
Yes, sir.
Okay. So types of ocean current. Two types of ocean currents are there based upon the depth. Okay. One is surface ocean current and the other one is deep water ocean currents, which means in ocean current, both the types are available. Okay. Ocean current is not just a phenomenon at surface level. Unlike the waves, ocean currents are both the phenomenon at surface level and deep ocean level. Am I clear? Whereas
Clear, sir.
waves are surface level phenomenon. Am I right? Waves are surface level phenomenon, which happens because of the friction of air with water, wind with water. Whereas ocean current is both surface level phenomenon as well as deep ocean level phenomenon. Am I clear? Shall we move forward?
Yes, sir.
Okay, good. Then ocean currents are classified into two different currents based upon the temperature. One is cold ocean current, the other one is the warm ocean current, which is very simple, right? Cold ocean current, you know the origination point, right? Cold ocean current, where does it originate? Where do they originate from?
High latitude area.
High latitudinal areas. Okay, near Arctic, for example, near Antarctic, for example. Okay, so high altitudinal latitudinal regions is where you can notice cold current, and you know about warm current near equatorial region. Okay, so cold ocean current moves towards warm ocean current, and warm ocean current moves towards cold ocean current. And as I said, clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. North right hand direction in the northern hemisphere and the left hand direction in the southern hemisphere. Am I clear?
Clear, sir.
And cold ocean currents are usually found on the western coast of the continent. If you calculate all these phenomenon, okay, the direction is from left to north, sorry, right hand direction, which means west coast of the continent only, right? Am I right? If water moves on right hand direction in the northern hemisphere, that means it's the west coast of the continent. Am I right?
Yes, sir.
If you consider Africa, even if you consider South America, okay, even if you consider South America, is it visible?
Not visible, sir.
Just a minute. Is it visible now?
Yes, sir.
Yes, sir.
Okay, right. So, what were we discussing? Okay, different types of ocean current, cold and warm, right? This is what we are discussing. Am I right?
Yes, sir.
Okay. Since it travels on the right hand direction, you can find the cold ocean currents on the western part of the continent. Is that right? If you consider South America or if you consider Africa, you can find it on the western part of the continent, right? Because you know that it travels on the right hand direction. Am I right?
Right, sir.
Since it travels on the right hand direction, you can understand why it is, that is the cold ocean current presence on the western side of the continent, right? And warm ocean currents can be found on the eastern part of the continent. Okay, so because again it travels on the right hand direction in the northern hemisphere. So if you consider from this position, this side is the right hand direction. Okay, see, the position of observer is very important here. Okay, if you are an observer standing here, this is the right hand direction for you. That's why you can see warm ocean current on the right hand side. If you are an observer standing from here, that is the point of origination of the current, this is the right hand direction for you. Am I right? Is it clear?
Yes, sir.
For warm ocean current, since this region is the origination point, it travels on the right hand direction, which is on the eastern coast of the continent. For cold ocean current, since this is the origination point, it travels on the right hand direction, so you can find it on the western side of the continent. Okay, the point of origination is very important. As I said, the other one, if you observe from southern hemisphere, it is left hand direction, and if you observe from the northern hemisphere, it is right hand direction. Okay, so just like that, from the point of origination of the current, so west and east are decided. Okay, so this is the reason why you can see warm ocean current on the eastern side of the continent and cold ocean current on the western side of the continent. Is it clear? Am I clear now? So far everything is clear, right? Do you have any doubts related to it? Because next we are going to see the positions and how difference of the current, temperature, and what kind of facilities it creates, what are the significance. If you understand this, then you will understand. Where is its origination? So does it vary? Question. Which one you are asking, Arjun? Is it current only, right? Cold and warm
Current.
ocean current.
Sir, current.
Yes, origination is different, right? Warm ocean current originates near equator, whereas cold ocean current originates near polar region. So origination position is different, right?
Okay, sir. Yeah.
Right. So see, if you stand near pole, okay, if you stand near pole and observe the earth, this is your right hand direction. If you stand near the equator and observe the towards pole, this is your right hand direction. Am I right?
Right, sir. Yeah.
This is what I was saying. Okay, so since their origination position is different, the movement of ocean current is different in both the sides. This cold ocean current in western part of the continent and warm ocean current in the eastern part of the continent. Okay, so now general characteristics of ocean currents, which I already said. Northern hemisphere it is clockwise direction, southern hemisphere it is anti-clockwise direction. The reason is Coriolis force. There is another name for Coriolis force, which is Ferrel's law. Am I clear? Coriolis force is
Yes.
otherwise known as Ferrel's law or Ferrel's force. I hope you know the meaning, because since it is found by Ferrel, and Ferrel was the guy who's behind the invention of this discovery of this ocean current, Coriolis force. He named the Coriolis force from his name itself. Okay, so Ferrel's law. Right? Am I clear? Shall we move forward?
Yes.
Right. So, an Indian Ocean has a beautiful feature. You know that we have two types of monsoon, north east monsoon and south west monsoon. So according to the seasons, the current in Indian Ocean changes its direction. Okay, the Indian Ocean currents, if you see, during the southwest monsoon time, it changes its direction, and again northeast monsoon time, it changes its direction towards other side. So these are the ocean currents, different ocean currents of the world. Okay. This one you already know. Labrador current and Gulf Stream meets off the coast of Newfoundland and Labrador in North America. Then, did I say two ocean currents meets near Japan also, which helps in the fishing in Japan? Did I say anything about it? Did we discuss anything about it? Fishing in Japan. No? Read in NCERT, yeah, okay. So, Japan, you know that fish is one of the most, fish is a staple food of Japan. Okay, because the reason is in Japan also two ocean current meets. Okay, just like in North America, ocean current meets near Japan also. The cold ocean current is known as Oyashio, and the warm ocean current is known as Kuroshio. Right? Here you are seeing two ocean current meets, Labrador cold and Gulf warm. Here also Kuroshio warm, Oyashio cold you are seeing. So which means wherever cold and warm ocean current meets, fishing develops in that region. Can you think of any reason? Can you guys think of any reason why where cold and warm ocean current meets, their fishing is developed in that region? Can you think of any reason?
More nutrients.
Good. How? Why? Maybe more food will reach there. Phytoplanktons. Good. Phytoplanktons development you can see in this place. Reason is the cold ocean current, which travels a long distance from the polar region, sinks and reaches the equatorial region. And you know that from equatorial region, upwelling happens. It floats on the cold ocean current. When they both meet, what happens is the nutrient-rich cold ocean current, it interacts with the warm ocean current, thereby the temperature somewhat becomes moderate, and the sinking cold ocean current, which carries nutrients, gets released in this zone. Okay, upwelling happens. Upwelling of nutrients happen in this region. So with nutrients, what happens is more phytoplankton growth. Since more phytoplanktons are there, more fishes will be there. Since more fishes are there, fishery industries are developed in these regions of the world. Right? Am I clear? So what you guys do is you have to mug up the cold and warm ocean currents. Right? Am I clear? This is your homework or this is your work you should do today. There's no other way. You have to mug up the names of the cold and warm ocean currents. Am I clear?
Yes, sir.
Okay. So you already know about Labrador and Gulf Stream. Okay. Then there is Canary current. Then there is Peru cold current is there. Then Australian hot current is there. Okay. So you have to memorize all these warm and cold ocean currents. Then Californian warm current is there. Sorry, Californian cold current is there. Okay, so you have to mug up the cold and warm ocean currents. That is your work today, because only when you know the names, whether it is hot or warm, you will know the interactions and why certain sectors and certain regions of certain places are hot, certain places are cold, and why the hot deserts of the world are concentrated on the western part of the continent where cold ocean currents are there. All these reasons you will understand once you mug up it. Okay, so that's your work for today. But anyways, I'll complete this one. Right? So you already know the warm ocean current moves towards the cold and cold moves towards warm. We know all these things: convergence, divergence. Okay. So the shape and position of the coastal also plays an important role, which you already know, because when due to the shape of the coastal region, the Mediterranean Sea water sinks and moves towards the Gibraltar region or Gibraltar region. So where is Gibraltar? Where is Strait of Gibraltar? Strait of Gibraltar. Where is Strait of Gibraltar? Guys, revise the map. Strait of Hormuz, Strait of Malacca, Strait of Gibraltar. Revise your map kindly. Right? So now the effects of ocean currents. Okay. One is desert formation. How desert formation is, we'll see that last. Okay, first we'll see rain. Okay, so effect of ocean currents. First, wherever warm ocean current is there, there you can see rainfall. Why? What is the relationship between warm ocean current and rainfall? What is the relationship between warm and yes, good evaporation? High evaporation and the property of warm air. The property of warm air is that warm air expands. Am I right? Warm air expands. Am I right, guys?
Right, sir.
When warm air expands, what happens is it traps the water molecules inside. That's why Calicut is a humid place, because here air is hot. Since air is hot, what happens is it traps the water molecules inside, because ocean is there nearby only. Since it traps water molecules inside the air, what happens is humidity becomes high. And when humidity is high, when evaporation is high, when temperature is high, those regions are known for rainfall. Am I clear? So what happens is
Yes,
this
sir.
ocean current, okay, since it is warm, the warm current, it provides more evaporation, and with more evaporation, more humidity. When more humidity means more rainfall. Okay. And also pressure belt plays a huge role in this development of rainfall. Okay, what the pressure belt or the wind pattern does is the warm ocean current and the warm air mass in the ocean, okay, the wind that flows from the west to east, it just pushes it inside. Okay, the wind that flows from west to east, what it does is it just pushes it inside. Sorry, not west to east, east to west. Okay, the wind that flows from east to west pushes the warm air mass inside the continent, thereby activating rainfall on the eastern side of the continent. Okay, and the classic example is British rainfall. We'll see more about this when we discuss about different climatic zones, different climatic regions. Once you understand pressure belt, this becomes more easy for you. Okay, so what you guys do is, as I already said, after reading the pressure belt, after understanding the pressure belt, once again come to oceanography, once again come to ocean currents and the features, then read it again, you will understand more. Okay, am I clear? The other one is moderating effect. I hope you already know about moderating effect. When the region is hot, the cold ocean current gives some relief. When the region is cold, the warm ocean current provides some relief. Am I clear? This one is easy, which you already know, right? Then fishing, as I already said, the richest fishing grounds of the world is where cold and warm ocean current meets. Example, the Labrador Current and Gulf Stream, and apart from that, Oyashio Kuroshio of the coast of Japan. Okay, when warm and cold ocean current mixes, as I said, upwelling happens. With that, the growth of planktons happens. With the growth of plankton, more fish. With more fish, developed fishing industries. Right? Am I clear?
Clear, sir.
Okay. And one more thing is, wherever warm and cold ocean current mixes, a foggy weather condition is created. Okay, when a cold ocean current meets warm ocean current, the huge temperature difference between them creates a foggy weather condition. Right? For example, people who wear specs, you must be knowing it. Right? People who wear specs, you must be knowing it. When you have this one, what is that? Mask. When you are wearing mask and the specs, what kind of problem you guys face?
The fog covers the glass.
Huh?
The fog covers the glass.
Yes, exactly. That's what the interaction between warm and cold ocean current also. Okay, so the people who wear specs and mask, you must be knowing about it, aware of it. So this is what happens when cold and warm ocean current meets. Okay, that is the foggy condition. Right, so this creates rainfall in many places, as I already said. Okay, this creates rainfall in many places. For example, British climate and also Florida of United States of America. So this happens in certain places. And navigation. Okay, ocean current helps in navigation. The speed of the ocean current helps in the navigation process. Okay, navigation becomes easy when the water is fast. Okay, the current is known as drift usually. When the drift is fast, what happens is it aids the movement of ships. Okay, so navigation becomes easy with the warm current. This is one more properties or one more help or significance of the ocean current. Now, the most important topic, which I said, desert formation and ocean current. Okay, so guys, after this you can go. Okay, so it would hardly take some minutes, because if I discontinue this tomorrow, I have to start from the first, where you would have forgotten many concepts. So I don't want to do that. Just wait for a while. We'll complete this and then wind up for today, right? Okay, now the desert formation and ocean currents. Major hot deserts are located between 20 to 30 degree latitudes and on the western side of the continents white. Okay, so this was a previous year UPSC question. And also the ocean currents and its significance, okay, related to fishing grounds, that was also one of the previous year questions. Okay, so questions from this region, okay, in UPSC previous year mains examination, if you take at least some considering the past 10 years, some 4-5 times questions came related to ocean currents. Am I clear? The past 10 years, if you consider, 4 to 5 questions came related to ocean currents. So ocean currents is a simple topic, small topic, where the possibility of question is high. Am I clear? Shall we move forward?
Yes, sir.
Okay, now you tell me. So what you do is you mug up the names of the currents. Now if you see, there is a correlation between desert formation and ocean current. Am I right? Sahara Desert, Canaries current is there. Mojave Desert, Californian current is there. Atacama Desert, Peruvian current is there. Kalahari Desert, Benguela current is there. Australian Desert, Australian current is there. So wherever the important deserts are there between 20 to 30-degree latitudes, you can see currents also, ocean currents also on the side. To be specific, all of these currents are cold ocean current. Am I right? Peruvian current is a cold ocean current. Californian current is a cold ocean current. Canaries is a cold. Benguela is cold. West Australian current is cold. But why, guys? Why, wherever cold ocean current is there, you are also seeing desert? What could be the reason? We already saw something. On the eastern side of the continent, we have warm ocean current. Warm ocean current helps in the development of rainfall, which means the opposite should be done by the cold ocean current. Am I right? Good, Biju. No evaporation. Am I right? Evaporation is more the eastern side, warm ocean current, and with the help of the wind pattern, wind pushes the warm air mass inside the continent, thereby giving rainfall. That's why if you see the eastern part of the continent, you can see heavy rainfall. This region, Georgia, Florida, are known for cyclones. Right? People who usually watch Hollywood movies, you might be aware of this. Florida rainfall, Florida cyclone. Am I right?
Yes, sir.
Yes. British climate, people who watch cricket, you must be aware of it. British climate means rainfall throughout the year. Whenever cricket match happens, cricket match gets cancelled because of this stupid climate there. I mean, rainfall there. Am I right?
Yes.
Right? People who watched last World Cup must be frustrated with the rainfall here. Okay, so the reason is the cold and warm ocean currents. Okay, so what happens with cold ocean current is, one thing is, wind flow is from the continent towards the ocean, that is offshore winds. Am I clear? The wind pattern is from east to west. This is how the wind pattern is. Am I clear? So wherever warm ocean current is there, rainfall is given. Rainfall is given. Amazon rainforest, Florida, okay, British, African rainforest, India, the coastal region of India, Indonesia. Am I clear? Do you see any pattern here? Is there a pattern here at all? Guys, are you there?
Yes, sir.
Okay. So what happens is rainfall on the eastern side of the continent and no rainfall on the western side of the continent, because whatever the rain bearing winds were there, it gives rainfall. All the rainfall happens in the eastern part of the continent, thereby leaving nothing for the western continent. So offshore winds is one of the reason. And then what happens is, as I said, the cold ocean current, okay, it creates a desiccating effect. Okay, desiccating effect means when the cold enters into warm region, what happens? When cold ocean current or when cold wind enters into warm region, what happens? When cold air enters into warm region, what happens? What happens, guys? Foggy atmosphere, right? So this is what happens wherever cold and warm ocean current meets. Okay, just like that, what happens is desiccating effect or desiccating effect it is. The desiccating effect is where when a cold region, a cold current, a cold air mass enters into warm region, what happens is the remaining little humidity is there, right? See, different humidities are there. Absolute humidity is there. Relative humidity is there. Now we have to concentrate on only relative humidity. Relative humidity is the measure of how much a wind can hold humidity and how much it is holding currently. The difference is called relative humidity. Am I clear? Relative humidity is nothing but how much a wind can hold humidity or water vapor and how much it is holding currently is called relative humidity. Am I clear, guys?
Clear,
You
sir.
understand? Yes. So what happens is, even though the little humidity available in the which region, for even though a little humidity, if it is available in Kalahari Desert, if you take for an example, when the cold current enters into this region, which makes cold air mass, right? When cold air mass, it usually won't enter because the wind already travels from east to west direction. Even if some air escapes, even some wind, if it escapes and enter into the desert region, what happens is it absorbs whatever the remaining humidity is available in the region. Am I clear?
Yes, sir.
See, it is cold, right? Since it is cold, when it enters into a hot region, it becomes warm. When it becomes warm and expands, what happens is the little humidity, whatever is left in the atmosphere, will get absorbed. Am I right?
Right, sir.
This is called desiccating effect. Okay, am I clear?
Yes.
Okay, so what I'll do is you guys mug up the names. Okay, cold and warm ocean current. Once again tomorrow, I will teach you why the desert formation happens in the western part of the continent. Once I teach you the pressure belt. Once after completing the pressure belt, I will come once again to this desert formation. Then we will discuss. I hope then you will understand better. Am I clear?
Okay, sir.
Right? So what we'll do is after this we'll leave the temperature, salinity, okay, those features of the ocean, and then we'll go to the pressure belt. Once pressure belt is completed, we'll come again in to the desert formation and ocean current, how it affects. Then you will understand better. So your work is to mug up the names of cold and warm ocean current, and it is also not that difficult, so you can easily mug up. Am I clear?
Clear, sir.
Okay, guys. Then thank you all. Have a good day.
Thank you, sir.